Okay, here we go, graphing logs. So last class we graphed exponentials, and what I have up here with Desmos is in the red is the graph y equals 2x, and the blue is y equals log base 2 of x. And we can see that they're inverses. If we took a line, let's see if I can, if we took the line y equals x, right, and we folded this graph over y equals x, we see that they would be right on top of each other, right? They reflect over the y equals x line, indicating that they're inverses, and we know exponentials and logs are inverses of each other. Now, technically, yes, that's true, except for they have to have the same base. You know, our exponent has the base of 2, and our log has the base of 2. Now, 2 to the x would not be an inverse of a log base 3, right? There are limits here. So let's talk about what the table would look like. Let me see if I can do this. Let's get some color here. Let's do a table for y equals, okay, let me put that down. Let's see if now it'll let me. All right, let's have y equals 2 to the x. And we make our table, we know, like, what are our besties, right? When x equals 0, y is 1. When x equals 1, y is 2. What do we know about the tables of inverses? We've seen inverses quite a few times, and we know that their tables are flipped. And so this is the little shortcut we're going to use. When we see log base 2, we're going to be like, you know, really hard to make a table because we're like, log base 2 of 1. Okay, it's just hard for our brains to think that way. But if we think, wait a minute, these two are inverses of each other, we could actually write the table for y equals 2 to the x and then just flip the x and y columns. And so our besties for exponentials were 0, 1, and then 1, and whatever the base is. For logs, it's just flipped. Our besties are going to be 1, 0, and then whatever the base is, 1. So here we go. What we're going to do is we are going to go to, I'm going to do 3 delta math problems with you. I'm going to do the first one, and then you're going to pause, and you're going to go and get it done on your own. So I'm going to be focused on the first thing, and that is, what is the base of my log? See, the base of my log is 4. All right, and so what that makes me think is that I'm going to be looking at y equals 4 to the x. All right, and because that is the flip of y equals log base 4 to the x. So it makes sense, right, that our parent function is right here. The rest of it, transformations, easy peasy. We want to get our 2 dots in and then start transforming. So let's think about the table here. The exponential, we know 0, 1, and we know 1, 4, right? But we're not going to graph those 2 points. We're going to flip it because the log base 4 is the inverse of 4 to the x. So we're going to flip 1, 0, and 4, 1. All right, then we're going to stop, go to this, and we're going to pull those 2 points over. We already have, there's already one at 1, 0. Let's see if I can pull this up. It's not letting me. Okay. I'm going to do 1, 0, and then this one's going to be 4, 1, right? And then what I want is I want a asymptote. So instead of a horizontal, right, with exponentials, we had a horizontal. Well, with the inverse of that, you get a vertical. So we're going to take that vertical and we're going to pull it here. Let me try to see if I can get, there we go. Okay. We can pull this up. All right, so now we've got some transforming to do, and there's lots to do here. One way I think is a nice orderly way to do it is to actually just start from the left and move all the way through, making sure we don't forget things. I know sometimes I'll do the left and right shifts or the up and down shifts first. Let's just go left to right. This 2 right here, so let me switch over to this. So this 2, a good green. This 2 right here is saying whatever your height is, multiply it by 2. So see how my height here is 0? I'm looking at, I don't want to really point to the, but my height here, right, is 0. Well, 0 times 2 is still going to be 0. That height's not going to be affected. But 1 times 2, right, that's going to be affected. So we're going to go ahead and we are going to pull this height. Let's see if I can switch over. We're going to pull this height up to, it's not letting me. All right, hold on a second. I'm not sure why it's not letting me pull over. Okay. So let's do this. Okay, so we're going to pull this over from the height of 1 to the height of 2. So we're done with that first part. Okay, the second part, see that x minus 2? Well, that minus 2 is going to be where we, right, the minus 2 means because it's next to its x, it's going to be the opposite. It seems like, oh, shift it to the left 2. No, we're going to do the opposite, okay? We are going to shift it to the right 2. So we're going to say, take this point, shift it to the right 2, and take this point and shift it to the right 2. Now, we have to stop for a second. Anytime we're shifting left or right, that asymptote is going to be affected. Remember when we were graphing exponentials, if we were shifting up or down, we'd have to drag that asymptote with us. So same thing here, because we have a vertical up and down asymptote, we have to, if we shift to the right 2, we have to take the asymptote and also shift it to the right 2. So just remember that. All right, and then lastly, we've got this, let's see, pick a different color. We've got this minus 4. This is just a vertical shift, like an up and down shift. And so what we're going to do is we are going to take this 3 and we're going to shift it down 4. 1, 2, 3, 4. And we're going to take this 2 and shift it down 4. 1, 2, 3, 4. Now, do we need to touch the asymptote? We do not need to touch the asymptote because we could shift it up and down all day. It's going to look the same. All right, let's see. Let's see if we get our green. Yep. Okay, you all go ahead and pause and then come back and let's do the second one. We only have 3 of them to do today. Okay, so let's do the second one. Checking my time, not too bad. Okay, so I want to identify first the parent function. And I'm going to pull this up right away so it's not that bad. Oh, I did not want to do that. Did not want to do that either. Let's just go ahead and do this. All right, so I see that my parent function is log base 2 of x. So let's see. So we've got this part right here is my parent function, right? Y equals log base 2 of x. And I think about what is that, when I think about the inverse of that, I think y equals 2 to the x is my inverse, right? Because 2 is the base, 2 is the base. I know how to do the table for this. Table for this is 0, 1, 1, 2. Table for this, because it's inverse, so we flippy-floppy the x and y columns, right? Okay, then we're going to go ahead and we're going to move our yellow dots accordingly. We already have the yellow dot at 1, 0, thank you very much. And then we're going to go to 2, 1. And then we're also going to get our asymptote in right away. All right, we've got a vertical asymptote, we're going to pull it to 0. Okay, we would be done if they asked us to graph this right here, y equals log base 2 of x, we'd be done. So now what do we have left? We have some, we've got some transformations to do. So let's go ahead and pick a color. Okay, I don't want that. Sometimes, okay, there we go. I want that. I want to pick a new color, like pink. Okay, so let's go ahead and look. Oh, look who's being negative. Our x is being negative. And what do we say when our x is being negative? We're like, why? Why do you have to go around and say negative things about me, right? So when our x is a negative, that's a sign we're going to flip over the y-axis because we say to ourselves, why? Why do you have to be like that? All right, let's go ahead and switch to this. Let's see if it'll let me do that. Nope, switch to that. There we go. So we're going to flip over the y-axis. This dot's going to go bloop on this side of the y-axis. So the same, see how this dot right here is 2 away from the y-axis? We're going to flip it on this side so it's 2 away. All right. The next thing is our +4, and we know that's up and down. Oh, by the way, did flipping over the y-axis, did that change our asymptote? Nope. And then we're going to add 4, so we're going to go up 4. 1, 2, 3, 4. And 1, 2, 3, 4. Wait a second. What happened there? Oh, I only went up 5. I only went up. There we go. Okay, there we go. I only went up 3. All right. So you know what? Now that we can do exponentials, logs don't seem that bad, do they? Let's go ahead and get our green check and then go ahead and pause and come back and let's do the third and final one.